So now we're going to talk about dividing decimals. If you're dividing decimals, you might be faced with a problem and an example that looks something like this. 8/10 divided by 4. Now, what does that even mean? Well, that scenario might mean something like this. You might have a story that goes like, if 8/10 is divided into 4 groups evenly, what is the size of each group? Now, if you think about it that way, and you take 8/10 and you divide it into 4 equal groups, because we know that division is the inverse operation of multiplication, it's easier to see that 2/10 is the answer. Because if you add 2/10 to 2/10 to 2/10 to 2/10, or if you multiply 2/10 times 4, you can get 8/10. So you can tell that 2/10 is the solution. So if you had divided 8/10 into 4 equal groups, each group would be the size of 2/10. So procedurally, when we're dividing a decimal by an integer, that means if we're dividing any kind of decimal number by an integer or a whole number or its opposite, remember we don't divide by 0. You want to keep track of the decimal point and you bring it straight up into your quotient. So for example, just like we just did 8/10 divided by 4, you would set it up 8/10 divided by 4. Well, 4 does not go into 0, but 4 does go into 8. How many times? Twice. And that's 2 times 4 is 8, so we subtract the 8 and we're left with nothing, which is awesome. Notice that decimal place came straight up, and we do in fact get 0.22. Okay, so if I were to come down here to this example, and I'm dividing 48 and 78/100ths by 6, what do you think that is? I mean, what would be a good estimation, a good guess? Well, I say over here, estimate to check if your answer is reasonable. You could do this beforehand or afterwards, just kind of get in the mindset. What would be a reasonable answer? Well, 48 and 78/100ths, if I'm working with 6, I'm comfortable with saying, well, 48 divided by 6 is 8, so my answer should be hanging around 8 somewhere. So when I set this up, it's 48 and 78/100ths divided by 6. The decimal point comes straight up. I can do that right away. 6 goes into 48 8 times. That's an even 48. So when I subtract it away, I get 0. But then I bring down the 7 because I'm not done with the number. 6 goes into 7 one time. That's 6. 6 one time is 6. I subtract that away and I get 1. And I bring down my remaining 8. 6 goes into 18 3 times evenly because 3 times 6 is 18 and I'm left with nothing. My solution is 8 13/100ths. And we said before that 8 would be a reasonable answer. It's wonderful that we came up with something that's close to 8 because it makes us feel really confident in what we came up with. So if we had an example like this, 71 and 6/100ths divided by 34, negative 34. This is a problem where you would have to use your integer rules, even though we're not working with integers. Think that your answer will be negative. Why? Because the signs are different. So you would go about dividing it just the same. You would say 71 and 6/100ths divided by 34. 34 goes into 71 twice. 2 times 34 is 68. When I subtract, I get 3. I bring down that 0, and it's important. It's so, so important to not forget this step. Does 34 go into 30? It doesn't. So we have to say it goes in 0 times. And when I do that, I changed colors because I wanted you to see you could bring down this 6 within kind of that step. And now that we've noticed that it goes in 0 times into 30, then I can say, oh, well, does it go into 306? Yes, it does, and it goes in 9 times, and it's actually evenly 9 times. 34 times 9 is 306. So we subtract it away, and we're left with nothing. A lot of times, a very common mistake is that students will say, oh, that's nothing, and I don't put anything there, and then I'll put the 9 over that 0 and get 2.9. Well, 2 9/10ths is not the same as 2 9/100ths. 2 9/100ths is the correct answer. In fact, negative 2 9/100ths is the answer. We have to remember that our answer is negative because our signs were different. So if I come down here to this example, I have a negative 80 and 1/10 divided by negative 9. I can think to myself, this is kind of my thought process in green, my answer will be positive because my signs are the same. So in my work, I can just leave them positive. It doesn't really make that much of a difference now that I've already made that connection. 80.1, 80 and 1/10 divided by 9. Well, 9 goes into 80 8 times, that's 72. 8 is left over, bring down that 1. 9 goes into 81. 9 times, 81 minus 81 is 0. And so I have 8 and 9/10 as my answer, and again, it is positive. Now here's the good stuff. When you're dividing numbers, you can multiply both of the numbers by any power of 10, the same power of 10, and it's not going to actually change your answer. Check this out. This is a non-decimal example. If I have 100 divided by 10, the answer is 10. But if I take 110 and I multiply them both by 10, the problem turns into 1,000 divided by 100. Guess what? The answer is still 10. This is always going to be true. Anytime you multiply both of the numbers by the same power of 10, I could multiply them both by 100, both by 1,000. My answer would still be the same. So that's pretty awesome. We use this property to help us when we must divide by a decimal. Now we're going to be dividing by things like 36 hundredths. Now that's kind of ugly, but if I wanted to change 36 hundredths to 36, I could just multiply by 100 and it would work. When we multiply by a power of 10, we can turn decimals into integers, which are much easier to divide by. So check it out. If I take, this is kind of funny. If I take 4 and 32 hundredths and I'm dividing by 3 and 6/10, I don't want to divide by 3 and 6/10. It's not easy to divide by a decimal. I would rather divide by an integer. So I'm going to say, well, I can multiply 3 and 6/10 by 10 and I get 36. Well, 4 and 32 hundredths, if I multiply that by 10, that becomes 43 and 2/10. So when I bring it over here to do my long division, it looks like this. 43 and 2/10 divided by 36. So now 36 goes into 43 once. Subtract 36 and I'm left with 7. I bring down my 2. 36 goes into 72 twice. And that isn't even 72 and there's nothing left over. Be sure you remember, and it's so important, that this decimal point goes straight up in your answer, okay? And I just made a note here to make sure, to look at the pattern kind of what's happening to the decimal place. A lot of times we point out the procedure and we don't make the connection as to what's happening, but you can see that the decimal point has moved the same number of times in both numbers. That's because we multiply by the same power of 10. So here we go. If I'm dividing 9 by 1 and 25 hundredths, it looks like this if I set it up initially. But what I like to do is I like to divide by an integer. Remember. So if I multiply this by 100, then I can make it 125. And I also have to multiply the 9 by 100. I have to multiply them both by the same power of 10. So it becomes 900. Because I changed both of them, the answer will remain the same as if I divided by the decimal in some fancy way. So what you may have noticed is that the decimal moved to the right twice for 1 and 25 hundredths to become 125, and the same thing happened with 9 to make it 900. A lot of times we just talk about that and we don't talk about why, but that's why. And so 125 goes into 900 7 times. That's 875, and then I have 25 left over. What can we do when we get to the end of 900, but we still have something left over? When we're talking about dividing decimals, we really don't like to talk about remainders anymore. It may come up in a story problem where it's necessary to talk about a remainder, but generally when we're dividing decimals, we want a decimal as part of our answer as well. So if it goes in 7 times into the whole number, if there's some left over, we can add a decimal. Well, the decimal's already there, but we can fill it in and then add as many zeros as we want to. Because adding zeros does not change the value in a number after the decimal point. You can add as many zeros as you want, and 900 is still going to be 900, no matter if it's 900.0, 900.00000, it's still 900. So I can add that 0, bring it down, turn 25 into 250, and then 125 nicely goes into 250 twice. We put that 2 there, making sure that the decimal we filled in here also does go straight up. It's there for a reason, so we can't forget about it. Okay, so our answer would be 7 2/10. Okay, and then in this final example, if I'm dividing -12 by -1 6/10, I know that my answer is positive because the signs are the same. I then say, well, I don't want to divide by 1 6/10. I don't like it, so I multiply them both by 10. And here I've shown you that I've moved the decimal place once. I moved that decimal place once, and I've filled in that 0 because I multiplied -12 by 10, so it becomes -120. Now 16 goes into 120 7 times. 7 times 16 is 112. I subtract that. I get 8 left over. Again, I have to add that decimal, put that straight up, add another 0, and then 16 times 5 is 80. So I subtract that out with nothing left over at this point. And remember that my answer is positive, so I'm good with 7 5/10.